Okay, so I've got this pendulum here. It's a 10-pound sphere, 4-pound rod, released vertically. Hey, this thing is going to go down, smash into the floor with a coefficient of restitution of 0.8. How far does it bounce back up? So again, we're going to break this up into kind of 4 stages, right? State 1 looks like this. State 2, this thing's basically traveling down with some sort of velocity right before it smashes. State 3 is right after it smashes, where this guy is going back up, right? And then state 4, it bounces back up to some elevation like that, okay? 1 to 2 is conservation of energy because only gravity is going on there. 2 to 3 is an impulse problem, so we're going to do momentum, conservation of momentum, angular impulse, coefficient of restitution stuff. And then 3 to 4 is again only gravity, so we're going to do conservation of energy. The thing I want to do before we get too far into this is I'm going to need to find the moment of inertia about 0.0 for this entire thing. So let's go ahead and take 2 seconds and figure that out before we get too far. Okay? Consists of a rod and a sphere. The rod about its endpoint is 1/3 ml squared, where m is 4 pounds, L is 2 squared, plus the sphere, which about its centroid is 2/5 m, which is 10 divided by 32.2 r squared, which is 0.3 squared, plus I have to do parallel axis of the sphere, which is going to be that mass again, which is 10 over 32.2 times 2.3 squared. So from this, I find that the moment of inertia about 0.0 is 1.82, and that is slug feet squared. Okay, so I'm going to need that to go through and solve this. So again, what we'll do is we're going to use conservation of energy for the first part. Let me just kind of do this so it doesn't get in the way. We can kind of separate that out. So going from 1 to 2 is conservation of energy, right? So KE1 plus PE1 equals KE2 plus PE2. And what I'm going to say is it starts from rest, which it does, and I'm going to call the endpoint 0. So initially, I've got PE of this guy here, which is going to be, so the rod has a mass or a weight of 4. Center of gravity is going to be 1 foot above, right, because it's at the midpoint. And then I've also got the sphere, which is 10 pounds times 2.3. And that's going to equal 1/2 I about 0.0, which is 1.82, 1/2 I omega squared. And we'll call this, omega 2 squared. So this would be essentially that. We're going to call that not omega 3, and omega 2. Okay? So 1/2 I, and again, that's I about 0.0 that I've got here because it's a point of pure rotation. From that, I can find that omega 2 equals 5.45 radians per second. Okay? Now, this thing's going to smash into the ground and head back the other way. I know that the coefficient of restitution is 0.8, so we're going to go ahead and use that equation. So it's going to be E equals VB3 minus VA3 all over VA2 minus VB2. Now the thing is the ground doesn't move, so we're going to say that guy goes away to nothing, right? So we will say negative V3, negative because now it's switching directions, right? It was going down, now it's going to be going back up. So the velocity of the sphere at 3 is going to be divided by the velocity going in. We have omega, but again, it's at 2.3 feet away. So that velocity coming in is 2.3 times the omega, which is 5.45 4 or 5, right? Again, because I know omega, I can find that v. Now I can find the rebound velocity. Oops, do it this way. So the velocity of that sphere at 0.3 is going to equal 10.02 feet per second. Okay, so it's essentially 80% of what it was. So that sucker is now shooting up at, and again, we're going to call this V3. Okay. Moving to the last one, we're going to use kinetic energy again. So KE3 plus PE3 equals KE4 plus PE4. Well, again, we're going to say this thing's down at its 0 potential energy. I know it ends at the point where it comes to rest, which is 0 here. So we'll start with KE3, which again is going to be 1/2 I omega squared. Okay, so it'll be 1/2 1.82. Now omega, again, I have the velocity. I can get it back to omega by dividing by 2.3. So it'll be 10.02 divided by 2.3 squared. Again, this is about 0.0. That's the kinetic energy on the rebound. And then that's going to equal how high it goes up. Okay, well, I've got two things that go up. I've got the rod, which has a weight of 4. And if you think about what's going on here, right, it's going to be, right, if here's your triangle here, right, it's opposite of that. So it's going to be sine. So it's going to be 1 sine of theta. Similarly, I'll have 10 times 2.3 sine of theta, because again, that's how far that sphere will bounce up from its 0 potential. Okay, this is one equation, one unknown. I can go through and I can solve and find that theta equals 39.8. So many of these problems we have to break up into these pieces, apply energy, apply momentum to some, and kind of step through piece by piece, finding each each state in the process to calculate the final thing that we're looking for.